surface tension. Our aim is to find the surface tension of water by capillary rise method. To do the experiment, we require the following: retort stand, cork, wooden stand, beaker containing water, pointer, capillary tube, and travelling microscope. Place the beaker containing water on the wooden stand beside the retort stand. Pass the capillary tube through the hole of the cork until it is immersed in water. Water rises into the capillary tube. Now pass the long pointer through another cork in such a way that its tip just touches the surface of the water. The travelling microscope has the following parts: eyepiece, vertical main scale, vertical vernier scale, objective, horizontal vernier scale, and horizontal main scale. Now find the least count of the travelling microscope. Adjust the microscope by the anti-clockwise rotation of the screw placed in front of the microscope and point it towards the capillary tube. Microscope alone is adjusted by anti-clockwise rotation of the screw in front of the microscope and then tighten it so that the water meniscus becomes visible. Focus the binocular using the screw so that the concave meniscus of water level is clearly seen. Rotate the fine adjustment screw in anti-clockwise direction to make the horizontal cross wire just touch the central part of the concave meniscus. Note down the main scale reading and vernier scale reading. Calculate H1 using main scale reading and vernier scale reading. Remove the wooden stand and the beaker. Microscope alone is lowered by anti-clockwise direction of the screw in front of the microscope, then tighten it. Rotate the tightening screw on the base of the microscope in anti-clockwise rotation. Then slide it over the main scale a bit. Place it in front of the pointer and then tighten it so that the tip of the pointer becomes visible. Rotate the fine adjustment screw on the top of the microscope in anti-clockwise direction so that the horizontal cross wire just touches the tip of the pointer. Note down the main scale reading and vernier scale reading. Calculate H2 using main scale reading and vernier scale reading. Calculate the capillary rise H using H1 and H2. Place the capillary tube horizontally on the adjustable stand and place the microscope in front of the capillary tube. Focus the binocular on the end dipped in water by rotating the left screw on the binocular in anti-clockwise rotation so that the inner circle is clearly visible. Adjust the fine adjustment screw on the top so that the horizontal cross wire rises up and touches the inner circle at B. Note down the main scale reading and vernier scale reading. Calculate the total reading. Record the total reading in a tabular column. Adjust the fine adjustment screw and make the horizontal cross wire just touch the inner circle at A. Note down the main scale reading and vernier scale reading. Record the total reading in the tabular column. Move the microscope on the horizontal scale by adjusting the fine adjustment screw on the bottom right of the microscope in anti-clockwise rotation. This causes the cross wire to shift to the left. Adjust the fine adjustment screw on the top so that the vertical cross wire rises up and touches the inner circle at C. Note down the main scale reading and vernier scale reading. Record the total reading in the tabular column. Rotate the fine adjustment screw on the bottom right of the microscope in the clockwise direction. This causes the cross wire to shift to the right and makes the vertical cross wire touch the inner circle at D. Note down the main scale reading and vernier scale reading and calculate the total reading. Then find out the internal diameter and internal radius of the capillary tube. We can calculate the surface tension of water using the formula. Surface tension T is equal to R into H plus R divided by 3 into rho into G the whole divided by 2 cos theta. R is equal to 0.06 into 10 to the power of minus 2 meter. H is equal to 2.4544 into 10 to the power of minus 2 meter. Rho is equal to 1000 kilograms per meter cube. G is equal to 9.8 meter per second square and cos theta is equal to 1. The surface tension of water is equal to 0.07275 Newton.